Welcome back. Today we will learn how to delete a node at given positions in a doubly linked list except the first node in the list. Here is the scenario that there is only one node in the list, and since it is a doubly linked list, that is why it is having a prep pointer which is pointing to null, and the next pointer here also pointing to null. And the start pointer here is pointing to the first node at 102. Now we ask the user to enter the position where the node is to be deleted. And suppose the user enters 1, that means he wants the node at position 1 to be deleted. Now this is a check that if start is null, then we should know that the list is empty. And if start is not null, but the start next is null, which is the case here, then we should know that there is only one node present in the list. Now here is another check that if user position is greater than 1, that means user has wrongly entered some value which is more than 1, but there is only one node in the list. Then you give him a message that there is no node at that location. And else means user pose is equal to 1. Then we can easily delete this node from this list. So what do we have to do? We write free start, because free function is an inbuilt function that will help to deallocate the memory at 102 that is pointed by the start pointer. So it gets deallocated, and we set the start pointer to null. So our job is over. Now here is another situation where the user pose is 1. That means user wants to delete the first node in the list. But in this case, the list is having 4 nodes in place of 1 node, as it was in the previous case. So you can see that the start pointer here is pointing to the first node at 743, and there is a temp pointer which is ready to point to the first node at 743 because we have written this line temp equal to start. If this node is to be deleted, then the node at 478, which is a second node now, will be the first node in the list. And if it becomes the first node, that means this one, then the prep pointer, which is pointing to 743 now, should point to null, isn't it? So we write start next prev equal to null. Why? Because start next means 478. You can see that. Now the prep pointer of the node at 478 is this one. So this will be loaded with null, right? So whenever this line is executed, this pointer becomes null now. Next, we write start equal to start next. Why? Because this will be the first node now, and this will be the second node, and obviously this will be the third node, and this node will be deleted. So star must point to the node at 478, right? Now 478 is with the next pointer of star, that means this. So start next means 478. So 478 will be loaded inside star. So when this line will be executed, then this will be replaced with 478 here, and this link vanishes and this link will be established. So you can see that star is now pointing to the node at 478, which is the first node now, and temp is still pointing to the node at 743, which we want to delete. So we take the help of the free pointer here that will help to deallocate the memory at 743. And one little thing to do, to avoid the dangling pointer with temp, we should write temp equal to null so that it becomes like this. So you can clearly see that start is pointing to the first node, which was second node before, and the prayer pointer of this node is pointing to null. So you have deleted the first node from this list. Now we have the same situation as before, but now the user wants the third node to be deleted. That means this one. So we write else temp equal to star, and star means 743. So temp also points to 743, that is the first node in the list. Now our plan is to move this temp pointer to the position where the user wants to delete the node. In this case, temp should point to the node at the third position because user has entered 3 here. Next, we write temp pose equal to 1. Why? Because we have to keep track of the position of the temp. That is, whether temp is in the first position or the second position or the third position, like that. So the variable temp pose will keep track of the position of the temp in the list. So we start with the temp pose equal to 1 because temp is pointing to the first node now. So here is your variable and it will be loaded with 1. Next, we write while temp pose not equal to user pose. Why? Because we want to move temp to the third position. Now, when it is in the first position, it is not that location or the position desired by the user. So, whenever the temp pose will not match with the user pose, we will move the temp 1 node forward. So, at this moment, temp pose is 1 and user pose is 3. That means it's not matching. So, since it is not matching, we get a true result from here in the while loop. So, we get inside the while loop and write temp equal to temp next. Now, what is temp next? Temp next is 478. So, this 478 will be loaded inside temp. So, temp will be loaded with 478, and as soon as 478 is there, this link vanishes and this link will be established. So, temp is now pointing to the second node, Now you have to keep track of the temp pose variable because temp pose is still holding 1. So we will go for an increment here, that temp pose equal to temp pose plus 1. So that temp pose becomes 2. Now we get back to this condition again to check whether temp pose is not equal to user pose. So we can say that temp pose is 2, user pose is 3. So the temp pose is not equal to user pose. So we get inside again and execute this statement. Temp equal to temp next. Now what is temp next now? It is 521. So this 521 will be loaded inside temp. So look over here, it will be replaced with 521 and the link will go like this. We have a second statement here, that is temp pose equal to temp pose plus 1. So this 2 will become 3 now. So that temp pose is equal to user pose. So we get back again to see whether temp pose is not equal to user pose. But what we see? We say that temp pose is equal to user pose. That means the while condition is throwing you false. So the while loop stops and we are sure that temp is standing on the position where the user wants the node to be deleted. So we write temp prev next equal to temp next. What is the meaning of this? What is temp prev? It is 478. That means this node. So the next of 478 will be loaded with 291 because temp next means 291. So you see here that this 521 is loaded with 291, and as soon as 291 is there, so this link breaks and this link will be established. Now on the other side, you want this pointer to be pointing to the node at 478. So you write temp next prev equal to temp prev. Now what is temp next? Temp next is 291. So the prev pointer of 291 is this. So this will be loaded with 478 because temp prev means 478. So you load this with 478, and as soon as you do this link vanishes and this link is established. So you can see that the second node is directly pointing to the fourth node and the fourth node is directly pointing back to the second node. Now you deallocate the memory at 521 with the help of the free function. So it goes like this. And of course you set temp to null to avoid dangling pointer. So this 4 will be replaced with 3 because now this is the third node. Let's clean up a little bit and it will be finally looking like this. So I hope you understood how to delete node in a doubly linked list in the first position when the list has only one node or the list has more than one node. Also, you learned how to delete a node from a doubly linked list at a position other than the first position. In the next video, we will talk about purple linked list. Thank you for watching and take care.